Question number 1 is asking which of the following can be the equation of this graph. So this is back to our previous chapter. We're going to look at where this graph crosses the x-axis. So we have an x-intercept or a root at x is equal to -4, x is equal to 0, x is equal to +2. And we are going to take into consideration that that is a turning point, meaning that I'm going to have two solutions to x equals 2. So when we write this in the equation, all of these roots are going to change sign when you put them in parentheses, when you make them factors. So x equals -4 is going to be x plus 4. X equals 0 is just x, so we can actually write that out in front. And then x equals 2 is x minus 2. So I can already eliminate some answers. We are going to look at, again, this as a turning point. Since this is a turning point, it gets x minus 2 as a factor twice. So again, a turning point is going to give us that exponent squared. And then this is an even function or an even degree function. So that is why it has the same end behavior. And it's flipped upside down, which means it's going to be negative. So they used 1/4, so it's going to be -1/4. Again, because my end behavior for my graph is down towards the bottom, it's flipped upside down, so negative. All right, so we're going to choose all the answers that describe the solutions to x squared equals -10. If I were to solve x squared equals -10, I would take the square root of both sides, and it would leave me with x is equal to plus or minus anytime you solve using a square root. And then when you have the square root of a negative when you're solving, it brings out the I for an imaginary number. So this is an imaginary number anytime you're taking the square root of a negative. And then all the rest of these are all part of being a real number. So since these are part of being a real number, it's not going to apply because there's two types of numbers. There's either real numbers or imaginary numbers. So if it's imaginary, then it's just imaginary. Okay, number 3, on a recent test, Jeremy wrote this question. Which of the following statements is correct about this question that he wrote? So I'm going to probably do that on a little separate sheet of paper to show some more room. If I were to solve this, what I'm going to do is I'm going to simplify this side to see if it gets me x equals 9. There's several ways to do this. You could cross multiply, but I think it's a little bit easier if I just look at this and simplify it. So if I want to simplify this rational expression or this rational function, I'm going to first factor. So when I factor the top, x squared minus 81 is the difference of two perfect squares. It's going to follow the formula a plus b, a minus b. And to get your a term, you do the square root of the first term. So the square root of x squared is x. To find your b term, you take the square root of the second term, which the square root of 81 is 9. So to factor the top of my fraction here, it would be a plus b, a minus b, or x plus 9, x minus 9. And then x plus 9, we aren't going to factor that. So on the left side here, this is what I would get. And then if I were to cancel out, to simplify, I get x minus 9, and that is equal to x minus 9. So Jeremy was correct in this question saying this, but what we have to understand is that whenever you're solving with a rational expression, you can never have 0 on your denominator. So the bottom of the fraction or the denominator can never be 0. So x could actually never be -9. So x equals -9 would be the only answer that does not work, because -9 plus 9 is 0, and that would give me 0 on the bottom of my fraction. So the equation is not always true. It doesn't work when x is negative 9. It's sometimes true when x equals negative 9, or it's always true except when x equals negative 9. So my answer is C, because it's always going to be true. Yeah, x minus 9 equals x minus 9, with the exception of when x equals negative 9, because x equals negative 9 would give me 0. Okay, which of these is a factor? So we're going to go ahead and factor this one using my procedure. What two terms multiply to give me x squared? That's going to be x times x. Two numbers that multiply to give me 6 that are going to add up to my middle term, negative x. That's going to be 3 times 2. So multiplying diagonally, I get 3x. Multiplying diagonally, I get 2x. This has to be a negative and a positive in order to add up to negative 1x. So carry over that negative, carry over that positive. My factors are x minus 3 and x plus 2. So I don't see x plus 2, but x minus 3 is going to be there for our answer. Number 5, we are going to simplify this complex rational function. So this complex fraction, what we're going to do is we are going to eliminate the denominators. And when I say denominator, it's the denominators of each of these 3 fractions. So we're going to get rid of x plus 3, and x. So you want to multiply by the LCD of these fractions, or of these denominators. So in order to cancel those 3 out, we would have to multiply each of our fractions by both x and x plus 3. So that they can cancel. So then I go through each of my 3 fractions and cancel. So x plus 3 and x plus 3 cancel to leave me with 4x for the top of my complex fraction. Over here, bottom left, x plus 3 cancels, and I'm left with x times 1, which is just 1x. Here, the x's cancel, and I'm left with 3 times x plus 3. So we're going to make sure we distribute positive 3 here and here, and I get positive 3x plus 9. So now I'm just going to combine like terms across the bottom of my fraction, and I get my answer. So what a lot of people are going to try to do is cancel out the 4x's, but we have to remember that you can only cancel out common factors. So 4x is not a factor. 4x plus 9 is a factor, but 4x is not a factor down on the bottom, so you cannot eliminate 4x. Or you can just remember, if there's a plus or minus following the term, you have to keep this whole thing together. Like 4x plus 9 is going to stay together. You can't break it apart by just throwing 4x out. So this stays as your answer. Okay, number 6, we are going to be multiplying our rational functions. So our procedure for multiplying is always to check that your expressions are in standard form. That's your first step. Step 2 is going to be to factor. Step 3 is to multiply across and cancel. So making sure everything's in standard form, this one looks good. It's x squared followed by the x term, x and then constant. So all of these are in standard form. So now we're going to move on to our second step where we factor. So if I want to factor x squared plus 6x, I could show you that work up here at the top. We are going to factor using GCF. So we're going to start by dividing out x from both of these terms. So you write down that GCF, open parentheses, and divide it out. X squared divided by x is x. 6x divided by x is just 6. So our x's are going to cancel there. And then we always want to double check our work. This is x times x, which is x squared, and x times 6x, which is 6x. So that is how we're factoring the top of this fraction, and I'm going to rewrite it here. X minus 4 isn't going to factor, so we'll just rewrite it. And then x squared minus 16, I will show that work over here. X squared minus 16, we have to memorize, follows the formula a plus b a minus b, because it is the difference of two perfect squares. So my a term is going to be the square root of x squared, which is x, and my b term is going to be the square root of 16, which is 4. So when I factor x squared minus 16, it's a plus b, a minus b, or x plus 4, x minus 4. So I'm going to write that on the top of my fraction over here, x plus 4, x minus 4. And then we're going to factor this last trinomial on the bottom, and I will do that over here on the side. I have x squared plus 10x plus 24. When I factor this, I'm going to use my procedure of what two terms multiply to give me x squared. It's going to be x times x. Two terms that multiply to give me 24 are going to be 6 and 4 that have to add up to positive 10x for my middle term. So multiplying diagonally, I get 6x and 4x. Both of these would have to be positive to give me positive 10x. Carry over the positive, carry over the positive. Your factors are x plus 6 and x minus 4 for the bottom of your fraction over here when I factor x squared plus 10x plus 24. So we get x plus 6, x plus 4. So many of you are going to start to cancel on this step, but I'm going to go ahead and multiply across before I start canceling. But if you start to cancel on this step, that is perfectly fine. So if I multiply across my fractions, I get this. Multiplying across the bottom, I get this. And then I start to cancel out. So x minus 4 goes away, top and bottom, x plus 6 cancels, and x plus 4. So remember, you can always cancel the factors as long as you have the same factor top and bottom. So I am left over with just 1x, just x. So my answer is D. 7, we're going to solve this equation and then check for extraneous solutions. So remember, extraneous solutions just mean any solutions that would give us 0 as a denominator. And we can't have 0 as a denominator. So that's why we always check for them. Okay, so to solve this equation, because we have more than 2 terms, we are going to multiply everything by the least common denominator so that we can cancel out all of these denominators. So we're going to multiply each of these terms by 20x so that we can eliminate 5, 4, and 20. And then we also need to eliminate x, which is why we're multiplying by 20x. So we'll multiply by 20x here, here, and here. So now what I'm going to do is I'm going to cross out, I'm going to cancel out with my denominator, and only the denominator. You always leave the top of the fraction alone. We're going to deal with that in a second. So for sure your x's are going to cancel, and then your 20 and 5 are going to cancel out, but leave you with 4. So what you do is you say, okay, 20 divided by 5 is 4. So I'm left with 4, and then I'm going to be still multiplying that to x plus 1. So you can use some parentheses and distribute, and you get 4x plus 4 for that first part of the equation. Then over here, our x's are going to cancel, and we're left with 20 divided by 4 is 5. And you're still multiplying that 5 by this numerator, the 2. So it's going to be negative 2 times 5 is negative 10. That's equal to, over here, I just have the 20s that are going to cancel, and I'm left with 1 times x is 1x. So what I'm going to do now is I'm going to combine like terms, and then I'm going to solve for x by moving x to the other side. Whoops, negative 6 is equal to negative 3x, divide by negative 3. Negative 6 divided by negative 3 is 2. So x equals 2. But what we always need to do is make sure we check for extraneous solutions, meaning making sure that this number, when it's plugged into our denominators, never gives us 0. So 5 times 2 is 10, so that's okay. 4 times 2 is 8, that's all right. So this is a good answer. It works. Number 8, we are going to graph each of these inequalities. So I'm going to graph y is less than. So we have to be able to read that as less than 2x plus 2. So I'm going to start at my y-intercept, which is always this number by itself. And then the number in front of x is our slope. So from here, I'm going to go rise 2, run 1, and then go the opposite direction. And because there's an underline in my inequality, I'm going to be drawing a solid line. And since this is less than, we need to know that this means shade below the line. So here's my line for 2x plus 2. And because it's less than, I'm going to be shading below this line. So I'm going to do that with my green highlighter. I'm going to shade underneath. Or you can just draw arrows. Sometimes we just draw arrows to show the shading will be underneath. Okay, now we're going to graph 2y minus x is greater than or equal to 2 by, first we need to get it in slope-intercept form, so we're going to get y by itself. So I'm going to move over the x. I get 2y is greater than or equal to x plus 2. Then to get y by itself, we're going to divide everything by 2. And I get y is greater than or equal to 1/2 x plus 1, because 2 divided by 2 is 1. So I'm going to graph this one. I'll use my, I guess, a pink marker. And I'm going to start right here at 1. And so we do need to know that this is greater than, and it's underlined, so we are going to be drawing a solid line. So we're going to start at 1. My slope is rise 1 and run 2. So rise 1, run 2, and then the opposite direction, and I'm drawing my solid line. Because this is greater than, we are going to shade above. So my shading for that pink line is going to be above, so this direction. Or if you like to draw arrows, you can draw arrows, meaning we're shading in this direction. So your solution set is always where the shadings intersect, or where the arrows are pointing towards each other. So your answer is going to be this shaded region here between those two lines. Right here is our answer. So we are going to choose, it looks like D. Okay, so based on our shaded region, our answer is D. All right, number 9, we are looking for the product that is equivalent to this. So what we're going to do always is make sure that everything is in standard form. So standard form is always going to be our first concern. So the top of the fraction is going to stay as 2x squared minus 72. But the bottom of the fraction, we're going to have to rewrite in standard form. So it's going to be rewritten as negative x plus 6. All we did was reorder that so that the variable came before the 6. Let me see, it's looking really bright. Okay, that's better. All right, so what we're going to do is we're going to factor the top using GCF. So I'm going to do that work over here. If I factor 2x squared minus 72, I'm going to divide out 2, and that leaves me with x squared minus 36. Again, distribute to check your work. 2 times x squared is 2x squared. 2 times negative 36 is negative 72. So I am not done factoring this. I have to factor x squared minus 36. That is the difference of two perfect squares. So you have to use the formula a plus b, a minus b. And your a in this problem is x. When you take the square root of your first term, it's x, and then your square root of your second term is 6. So when I factor this, you leave the GCF 2 out in front, and then x squared minus 36 is x plus 6, x minus 6. So that is how I'm going to rewrite the top of my fraction. So I'm just rewriting 2 times x plus 6, x minus 6. All right. The bottom of the fraction, negative x plus 6, I am also going to factor. I can show that work over here. Negative x plus 6, I'm factoring by GCF. I can never have the negative as my leading term, so I'm going to be dividing out a negative 1 and that's going to leave me with x minus 6. So when I distribute, I get negative x plus 6. And that is what I had here, negative x plus 6. Again, you can always distribute all of this to make sure you have this here, and distributing here would give you this. So once you're done factoring, you are going to cancel out your common factors. So we have x minus 6 here and here, and then nothing else is going to cancel. So we're left with 2 times x plus 6 over negative 1. And then anytime you have 1 on the bottom of your fraction, it doesn't mean anything. So what we're going to do is dividing this by negative 1 just makes the answer negative. So my answer is B. Number 10, we're looking for which one of these is equivalent to this complex. Here it's 3 over 5 plus 6i. And then we're going to multiply by the complex conjugate. Again, to simplify this, you just take the bottom of the fraction and change the sign between the real and imaginary number. So I'm going to be multiplying 5 minus 6i to the top and bottom of my fraction. So on the top, when I distribute and I get 3 times 5, I get 15. 3 times negative 6i is negative 18i. The bottom of the fraction, we are going to be distributing the 2 binomials here with the 2 binomials here. So it's 5 times 5 is 25. 5 times negative 6i is negative 30i. 6i times 5 is positive 30i. And then 6i times negative 6i is negative 36i squared. So all we need to do now is simplify and combine like terms on the bottom. So 15 minus 18i. And then negative 30i and positive 30i, when I go to combine those, they cancel each other out to give you 0. And then we do have to remember that I squared actually means negative 1. So we'll do negative 36 and replace I squared with negative 1. So that is going to give us 25. And then negative 36 times negative 1 is positive 36. 25 plus 36 is 61. So they have our answers in this form, which means we need to break this apart as 15 divided by 61 and also minus 18 over 61i. So our answer is A. Number 11, they're telling us our parent function is x squared, so it's going to be a parabola at 0, 0, and then we can just kind of do our parent function. Whoops, I'll draw the parent function here. It's always at 0, 0. There's our parent function f of x. So what they're asking us to do is to apply these transformations, and I'll just wipe this out so no one gets confused. We're going to apply these transformations and then pick our new function after the transformation. So I'm going to rewrite for you guys the formula for our quadratic. So this would be the form of our quadratic equations where the number out in front is going to tell you whether it was a vertical shrink or vertical stretch, depending on if it's greater than 1 or less than 1. The h is always your translation, so your translation left and right. And k is always your translation up and down. So we're going to fill this in with this information. So based on this, they're telling us it's going to be a vertical shrink by a factor of 1/2. So in our equation, the a value is going to be 1/2 because of this right here, vertical shrink, which means graphically our graph's going to be shrinking down as a vertical shrink like this. A reflection in the y-axis, which means this is going to flip over the y-axis. But since it is positioned here on the y-axis already, when we reflect over the y-axis, it remains unchanged. because if I were to take this side and reflect it, it would land right here. And if I were to take this side and reflect it, it would land here. And the same thing happens for after the vertical shrink. When you reflect over the y-axis, it's not going to affect my numbers for this case. So after that, I'm going to translate 4 units down. So right here, we're not going left or right, so it's going to stay as x squared without a number being added or subtracted because we're not going left or right. This number out here is going to tell us whether we're going up or down. Since it's telling us down 4, then we're moving down 4. And that goes over here. So our answer is A. Again, the 1/2 is our vertical shrink, and then down 4. Reflecting over the y-axis didn't change our equation because the graph just lands on itself. Number 12, if I squared is -1, then what is I to the 24th power? So for this, we are going to need to remember our powers of I. And here they are. We want to memorize I1, and the 2 in the middle are negative. So remember, these are our remainders. We're going to be dividing this by 4. You always divide your exponent by 4, and whatever your remainder is will tell you your answer. So when I divide 24 by 4, I do not get a remainder. So I get I to the 0 power. Anything to the power of 0 is 1, or we can memorize that from here. So my answer is 1. Number 13, we're going to perform this subtraction. We want to remember that when we're just subtracting the two fractions, we are not trying to eliminate the bottom of the fractions. In order to add and subtract fractions, you need a common denominator. So in order to find your common denominator, you want to make sure that it's very clear what the factors are in your denominator. So the first thing we're going to do is factor this denominator. So my first fraction is going to be 2x plus 3, and then when I factor this, I can show that work on the side, x squared minus 6x plus 9. You look and see what two terms multiply to give you x squared. It's going to be x times x. Two terms that multiply to give you 9 and add up to negative 6x are going to be 3 and 3. Multiplying diagonally, I get 3x and then 3x. They both need to be negative to add up to negative 6x. So my factors are x minus 3 and x minus 3. So I'm going to write that in for the bottom of my fraction. Then this fraction over here, the denominator is already factored, so I'm going to leave it like this. So in order to add these or subtract these fractions, we have to have exactly the same denominators. So far, this side only has one x minus 3, so we need to multiply another x minus 3. Whatever you do to the fraction when you're adding and subtracting, you do to the top and the bottom. So over here, this fraction is going to stay as 2x plus 3 over x minus 3, x minus 3. And over here, we're going to distribute a negative 5. We have to be careful. This is negative 5. That's distributing. And we get negative 5x plus 15. And then this is x minus 3, x minus 3. So now that I have my common denominators, I'm going to combine like terms across the top. We have 2x and negative 5x to give us negative 3x. 3 plus 15 is 18. So here, if we look at our answers, they rewrote the top, and then these x minus 3, since there's two of them, they just wrote x minus 3 squared. So that's how we got D for our answer. Number 14, the variables x and y are varying inversely. So that means we are going to be using this formula where a is any number. They want y to equal 1 and x to equal 4, and we're going to write an equation that relates x and y. So we're going to plug in 1 for y, and we're going to plug in 4 for x to the formula. So what we're going to do is we're going to solve for a by moving over the 4. So to move over the 4, you're going to multiply 4, and we get 4 times 1 is 4 is equal to a, because the 4's cancel right here. So if 4 is equal to a, all you do is plug it in to the formula, and your answer is y equals 4 over x. Number 15 is asking what are the solutions to this quadratic equation. So what we want to do is make sure that we are understanding when it asks for solutions. We have several methods. We can do our factoring method. We can do several methods, but based on our answers, we're going to want to use the quadratic formula. So we have to memorize that the quadratic formula is opposite b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. So you look at all of your terms here. The coefficients are going to tell you that a is 5, b is negative 1, the number in front of x, negative 1, and then your constant is your c, negative 4. So you're going to take these numbers and plug them into the formula. So when you do that, it's negative b, or opposite b, meaning you take your b and change the sign. So it's going to give us positive 1 plus or minus b squared. So we're going to have negative 1 squared minus 4 times a times c all over 2 times a. So this is going to be 1 plus or minus negative 1 squared is positive 1. Negative 4 times 5 is negative 20. Negative 20 times negative 4. Maybe I'll write that down here at the top. Negative 20 times negative 4 is positive 80, because multiplying two negatives gives you the positive. This is all over 10. 1 plus or minus square root of 81 all over 10. And if you look at our answers, they are actually going to break this apart and divide the 1 by 10 and divide square root of 81 by 10. So our answer is C. We would make sure not to choose D. D would be if you had a negative 1/10, and then the I would mean there was a negative underneath the square root, and we did not have that. Number 16, which of the following graphs represent a vertical stretch? So what I wrote in that previous problem was that this is going to be our formula for our vertex form of the quadratic. So this number out here is going to tell you whether it's a vertical stretch or a vertical shrink. Anytime it's a vertical stretch, that A value has to be greater than 1 in order to be a vertical stretch. A has to be greater than 1. So if you look at D, this means it has an A value of 1, so that can't be your answer. It has to be greater than 1. 2/3 is less than 1, so that can't be our answer. 5/2 is a good answer. We want 5/2 because 5/2 is greater than 1. So ignore the negative when they talk about vertical stretch and shrink. Some people might say, no, that's negative 5/2, so it's less than 1. You ignore the negative. The negative is just telling us it's being reflected. That has nothing to do with the vertical stretch or shrink. Number 17, we're factoring this binomial, which is the sum of two perfect cubes. So we're going to be using the formula a plus b times a squared minus ab plus b squared. It's a formula that we need to memorize. To find your a term for your equation, you would take the square root, the cube root of your first term. So the cube root of 125, meaning what number times itself again gives you 125, is 5. Then the cube root of w cubed is w. Your b term you're going to find by doing the cube root of the second term. So the cube root of 27 means what number times itself gives you 27, that's 3, and the cube root of y cubed is y. So this is your a, this is your b, you're going to plug them into this formula. So it's going to be 5w plus 3y for a plus b. Then it's going to be a squared. So hopefully a squared, we are going to do 5w squared. 5w squared is going to give us 25w squared. Then minus ab. ab just means we're going to take these and multiply them together and get 15wy. Then we're going to be adding b squared. b squared is when we take b and multiply it to itself. and that's going to give us 9y squared. So my answer is A. Number 18, we're adding fractions again. So our procedure is to add using common denominators, which means the number on the bottom of the fractions need to be exactly the same. So in order to figure out the common denominators, you're going to want to factor your denominator here first. So I'm going to rewrite this. 49x squared minus 81 is the difference of two perfect squares. So I can show you that up here. 49x squared minus 81 is going to follow the formula a plus b, a minus b. So to find your a term, you do the square root of 49x squared. That's going to give you 7x. Your b term is the square root of 81, which is 9. So to factor the bottom of this fraction, it's going to be 7x plus 9, 7x minus 9. A plus b, a minus b, because this is the difference of two perfect squares. Then we're just going to copy down the second part, and we want to now get common denominators. So far it has 7x plus 9 in common. We are just going to multiply also 7x minus 9. Whatever you do to the bottom, you do to the top. So I'm going to keep my first fraction, 9 over 7x plus 9, 7x minus 9. And I'm going to distribute 5 times 7x and 5 times negative 9 to give me 35x minus 45 all over 7x plus 9 times 7x minus 9. So our procedure for adding and subtracting fractions is we keep the common denominator and combine like terms across the top. So 35x is going to stay, it has no other x term to combine with. Then we have 9 minus 45 to give us negative 36. So this would be my final answer. My answer is C. Number 19, we are simplifying this. So our procedure is going to make sure it's in standard form, which it is, and then we're going to factor and then cancel out common factors top and bottom. So the top of the fraction cannot be factored. We're going to leave it. The bottom of the fraction can be factored, and I will show that. That's factoring by GCF. So what we do is we divide out the largest that we can. So we can't divide out any numbers from 7 and 11, but we can divide out x to the 4th power. So when I divide out x to the 4th power in open parentheses, it's leaving me with 7x, because 7 has nothing to divide with. X to the 5th divided by x to the 4th is x to the 1st power, because you subtract those exponents. Minus 11, and then our x4s cancel. So the bottom of the fraction should be x to the 4th power times 7x minus 11. Now what we need to do is cancel out. Up here, x to the 5th power means there's 5 x's being multiplied. X to the 4th power means there's 4 x's. So from the bottom, we can cancel out 4 x's. From the top, we can cancel out 4 x's, but it's still going to leave us with 1 x because there were 5. So the top of the fraction is 2x. Bottom of the fraction is just 7x minus 11. So my answer is C. Number 20, we're going to find the zeros, which is another term for finding solutions, finding x-intercepts. When we have our quadratic equation, the easiest method to use is factoring. So what I'm going to do is I'm going to factor and then set my factors equal to 0 to find my zeros. So x times x multiply to give me x squared. 7 times 3 multiplies to give me 21, and that's going to add up to 10x. So multiplying diagonally, I get 7x and 3x. These will both need to be positive to add up to 10x. So my factors are x plus 7 and x plus 3. So I'm going to take each one of these factors and set them equal to 0. So I get x equals negative 3, x equals negative 7. All right, we are going to solve this equation and check for extraneous solutions, meaning check to make sure our solutions don't give us 0 on the denominator. So our procedure, when there's two fractions, each of these are equal to one another, we are going to cross multiply. So when I do that, it'll be 2 times a plus 1 is equal to 2 times a squared minus 1. So when I distribute, I get 2a plus 2 is equal to 2a squared minus 2. Since I have a squared in a terms, my procedure is going to be to move everything to one side and factor. So I'm going to move over 2a by subtracting 2a to both sides. I'm going to move over the 2 by subtracting 2